So my name is Andrew Wade, and I work at HPE as a Cloud Solutions Architect. So what I wanted to talk to everyone about today was a automated server patch management framework that I've created in operations orchestration, and I just wanted to show everyone how I created that and then set everything up. So the idea behind it is in today's large enterprises, patch management can be very time consuming and can be quite difficult because with patching any of your servers, you have a lot of stuff to do, including disable monitoring, re-enable monitoring, adhering to change control timeframes, getting all the servers scheduled to be patched, keeping up with if there's any issues with patching the actual operating system, ensuring that your applications themselves are gracefully stopped, doing managed reboots of the servers, ensuring that your applications are started back up. So there's a lot of work going into patching a system and making sure that after the patch, everything worked as expected and the application is back up in service, back in monitoring, and everything checks out all within the change control allotted for the actual patch maintenance. So that's why I wanted to introduce this patch management framework as a way to help provide governance through the entire patch process to make sure you hit all those key items. So we're going to go into what components we're going to show today in this example. So today we're using Server Automation as our backend system that's hosting the actual patch repositories for the Windows and Linux operating systems, as well as hosting the scripts for the application availability for stopping the applications gracefully, starting them back up. Um, and then we're using operations orchestration as the main workflow engine, and then Sitescope to be our monitoring system of choice that we're going to start and stop monitors for this entire patch process, and then ServiceNow for our ITSM ticketing system for when we go in and we create the tickets and we close the tickets, update the tickets through the entire life cycle of the product. But the big thing I want you to keep in mind is the idea behind the framework is that everything can be swapped out. So if you're using Microsoft SSCM for your Windows patching, then you would be able to swap out that component instead of using server automation in there, or if you're using Red Hat Satellite for Red Hat, anything like that. So we can swap components in and out to make the framework very adaptable to how your ecosystem is. And same thing with the monitoring systems, because I'm sure all the big enterprises are going to have lots of monitoring systems across the enterprise. So we'd be able to integrate with multiple monitoring systems and determine which monitoring system we need to query to find that particular OSI, depending on what kind of OSI it is. So the actual patching framework that we're going to talk about, so this is kind of a visual diagram of what it does. So if we start in the top swim lane, we'll see it's called scheduling slash self-service. So the idea behind it is in your enterprise, you would have a CMDB or all multiple databases that are kind of your source of truth that kind of index all the different CIs you have within your enterprise. So these are the target servers that you know you want to patch. So the idea is that we would integrate into those particular servers for the CMDB and ask it, okay, in the next 24 hours, give me a list of all the servers that have a vulnerability management window within this next 24 hours that we want to patch, and go ahead and schedule them within Operations Orchestration Central Scheduler to be scheduled to patch on that particular day. And the other model we'll talk about is self-service, where one-off, I want to patch this particular server right now. So we're going to show the automated scheduling persona real quick. Does anyone have any questions before I go into that? Okay, so this is operations orchestration. And what I'm going to do is show you the actual patching forecast flow. So this is the patch forecast flow. So the idea behind it is it would also be scheduled to be ran every 24 hours automatically. And we can see we have email notification on it. So when I click run, what is it actually doing? So the idea behind this particular forecast is it's going to read my particular database. So I have a database that serves as my CMDB, and it has a list of all my server CIs, and it does a query on that particular database to say, I want to know all the servers that are going to be patched today. So it determines what today is, and then it does a specific query onto my CMDB to get all the list of servers that are scheduled to be patched within this next 24 hours. And then after it gets the list of those servers, it'll go ahead and create a change control ticket. And then for each server, it's going to schedule it within OO Central Scheduler. So if I look over at Scheduler, I can see now it found a little bit less than a dozen servers, and it went ahead and scheduled them at their appropriate times that they were scheduled to be patched. So whether it was today at different times this evening or tomorrow at these particular times here, and it went ahead and integrated with ServiceNow. So the integration with your ITSM ticketing system can be any ticketing system, whether it's Service Manager, ServiceNow, or any of the other ITSM that your particular company is using. So if I take a look at this, so what it did is it found that this particular server, which is a Tomcat server, it was scheduled to be patched at this particular time. So it went ahead and created this change control. So within ServiceNow, it created a new change request for that set of CIs that it knew was going to be patched in this next 24 hours. And it created this particular change control. So that is 30026. So it went into ServiceNow, did a creation for the change, and then notated all the different servers that it was going to patch. So because this is just a demo instance, we didn't have actual CIs, but we would be able to relate all the CIs, so take care of the entire ITSM set of processes, and including making sure that we're assigned to the appropriate approval group. So this is just to get everything scheduled. And in this particular use case, the automation is creating the change for patching these particular server CIs. So now that those servers are going to be set to patch, we're going to go into the next persona. So if I go back over to my slide, we talked about how we can integrate with the CMDB, get all the information about the CI, and then next is the self-service. So let's go ahead and take it through this patching lifecycle. So when we go into self-service mode, we're just going to initiate the patching on one of these particular nodes instead of waiting for that scheduled time to happen. And this is what we're going to go through. So we're going to go through each one of these areas. So we're going to send out start notifications. Because we integrated with our CMDB, we can pull information from the CMDB about who the stakeholders are about that server, who the server owners from an OS, middleware, or application side are. So we can collect all that information about the server so we can send out email notifications to all the appropriate stakeholders that the patching is about to start. So the next thing we'll do is go into change control and check to see if the ticket is opened and if the ticket has been approved. So this is the hard toll gate for making sure that the change controls have actually been approved before proceeding with patching the individual servers. And because of the way the scheduler works, each server has its own flow set up in operations orchestration. This is a per server process. So if server A was not approved, but server B was, then the appropriate server will continue with the patch process that was actually approved in change control. And then it's going to go into monitoring to disable monitoring for the session and then re-enable it later. Same thing with security scans. So it's going to run an external vulnerability scan against the server before and after the patching sets, and then it's going to identify which application scripts need to be ran, and we'll get into more details on that a little bit later. Then it will patch the server and reboot the server. So let's go ahead and run one of the servers through the framework. So we're going to go ahead and choose this Apache server. So I'm going to just pull up its name real quick. And right now I'm doing everything through the central UI. So naturally, if you have any front-end service catalog, you would be able to expose all this within your service catalog to kick it off, or extend the ability to just invoke it via API if you wanted to. So here I have option for server name and whether or not to skip Nexpose. So Nexpose is our vulnerability scanning engine. And the only reason we put this here is because it takes a lot longer to run the scans. It takes an extra 6 minutes for each scan, so it adds 12 minutes to the process. So we're going to go ahead and run one server without the vulnerability management being ran against it, and then we'll do a second server. So the first one is a Red Hat node, and then the second one will run it on this Microsoft SQL Server. So the idea behind the automation framework is it's also cross-platform. So each one of the operations will determine if the server is a Windows or Linux, or what version of Linux or Windows it is, to make sure it hits all the appropriate steps relative to that. Oops, I ran it with skip and expose. So we'll run one more against, we'll do it against the IIS server. And then we'll jump into the actual workflows that are being ran and go into details on those. So let me start this one as well. So we'll change this to have it go ahead and run the vulnerability scan. So let's take a look at what's actually happening. So we can see that when we run the self-service patching, what it does is it runs the exact same workflows that the scheduled patching does. So it'll go ahead and open up a unique change control ticket for each one of the servers that are ran through it, and then it will go ahead and kick off the scheduling immediately. So we can see that the Apache server is being ran with this particular change control. So the idea behind making sure that the run names are set like this makes it a lot easier for when you go back in and you want to see details about a server that's been changed. So you can either search by the change control within the run name filters or by the server name itself. And now it's going to start going through the actual process. So because Central likes to jump around as flows are being ran, we're going to go ahead and take a look at it from Studio, which is a little bit easier to see. So the idea behind it is each one of those modules that we talked about before in our PowerPoint, those would be notifications, change control, monitoring, security scan, application availability, patch remediation, server reboot. So each one of those are modeled here as well. So I did call outs to help you see the sectionalization to it. So the first thing it's going to do is the start notifications. So this is just some information to get what the server automation name will be, just because server automation wanted to make sure that it strips the FQDN off of the server input if those are ran in self-service, so we get the appropriate node and server automation. And then we see that the start notifications are sent out. So part of the inputs to this flow are the email to items. So within the automated scheduling, when it got information about all the CIs, it also got information about all the stakeholders and their email addresses. So that's how you make sure that the start notifications are invoked to the appropriate people. And the next thing it does is after sending the notifications, it's going to check the change control request. So in this case, what this does is it runs a subflow to go into ServiceNow and check whether or not the change record is open and approved. And based on whether it is approved or isn't approved, it'll proceed with the flow or cut out and not proceed. So the idea behind this is we have a full exception process. So anytime we run into an exception, we have an exception exit workflow. So that's going to make sure that the application is still started up, that the information about the operating system is collected, service requests are updated with the fact that there was an issue, this node needs to be rescheduled with this patching vulnerability, and that's where you can dispatch additional incident tickets or anything like that. So you can capture all the information within your workflow about why the exception happened and make it very plain text within the ticketing system. So when someone actually needs to go look at it, they have all the information they need. So after it checks the change request, everything has a start and end time generator around it. That's so you can get better resource tracking of how long it takes to go through each module. So the next thing it will do is the pre-patch server health. So this one's a little bit easier to actually look at. So if we look at that module when it does the pre-patch server health, we can see that's where it is right now. So the idea behind this is before you do any patching on your server, you want to make sure the node is up and the node is working properly. So that's why you want to make sure that you're able to RDP into the box or SSH into the box, run some sample commands, and that way you have a good known before state. Because the last thing you want to do is patch a very large infrastructure and run into a problem where you get all these failures, but they weren't because of the patching. They were actually because the server wasn't healthy in the very beginning. So the idea behind this is make sure you have a solid baseline on the application health and the OS health before you start your patching process. So that gives you better analytics about your environment and what things looked like before you ran into it, before you started with it. Um, so that's why it does that. And then getting the OS information. So this is getting information about your operating system before any of your patching happens, including your kernel levels, your patches that were already applied. So it's to help see before and after. And this is also split into cross-platform so that you pull the appropriate metrics, whether it's Linux or whether it's Windows. So we have some WMI calls on Windows that get different information about the last time it was booted, the last patches that were set up, and same thing with Linux. So the idea is you can get all the information you want from your operating system before and after the patch sets. So we also have an integration into posting to the Slack channel. So this is just to show that we have lots of ways to give external feedback to what the automation is doing. So you can see here, it was a post to Slack about the information about what servers are actually being patched, what the change control was, just so you can see it as a higher level. So the idea behind this is you can expose things to chat ops or custom dashboards, update enterprise dashboards. Another thing that you can do is we integrated this with a custom dashboard I wrote in PHP. So when you have like 150 servers that are being patched concurrently, it's kind of hard to keep up with what servers are being patched. Management always wants to know, and it takes a little bit of work to get it all together. So the idea behind this is a current representation of everything happening in operations orchestration. So within each one of these flows, we see these database updates where we update the patching dashboard. So the idea behind this is we know exactly what step we are on for each one of these servers, as well as servers that are scheduled, whether they're in progress, and then you can sort by the change controls or the servers. So you have lots of visibility into what's happening. And this is kind of to showcase that we can also integrate with any other operations dashboards you have in your operations control room or anywhere else that you want to put live reporting data. So if we continue, we see these servers are running through the steps pretty quickly. So in terms of our workflow, we talked about the change controls. So next it ran into disabling monitoring. So the idea behind this is when we hit that module, so after getting that the server's healthy, we want to disable monitoring. So with this one, we have a simple subflow for disable monitoring. So in this case, we have Sitescope. So if I do a refresh real quick, we see I have that same set of servers and we have ping monitors set up on them. And we can see that the automation went in, disabled the ping monitor. So typically in your environments, you have a more complicated system of monitors and lots of different types of monitors. So the idea is we can crawl through all the monitoring systems you have, finding matches to that host name or IP, and then disabling each one of those monitors and tracking which ones we disabled. so that we can recursively hit all your monitoring targets and make sure that all the monitors are disabled. Or you could do a check to make sure they're up already and be able to generate some reporting and analytics on that. As well as the follow up later, we're going to see that the monitors are re-enabled. And this, of course, is because we have an approved change. So that's why the monitors are being disabled, since there will be a reboot in this process. So that's the monitoring task. So the next one is the pre-patch vulnerability assessment. So this may not be a requirement at all enterprises, but some of them require that we have a pre and post vulnerability scan. So this is through different external vulnerability scanners, such as Nexus or Qualys. In this case, we're using Nexpos as an appliance. And what it's doing is it's going to run a particular vulnerability scan against our server. So we chose it to do that against, it wasn't the Apache server, it wasn't this one, it was the IIS server. So we can see right now it's doing the vulnerability scan. So we'll come back and check out the update a little bit later. We can see it's running the pre-patch security scan. So after it runs that, it's going to next set the patching window timer. So this is really important. So depending on the type of server you're patching, if it's a regular application server, you probably have a window of maybe 2.5 hours or less, somewhere around there. But if it's a database server, like a Microsoft SQL server, or perhaps a Oracle RAC server, something like that, you're going to have a higher time window just because it takes a long time to gracefully stop processes and bring the server up, down, memory checks, all that good stuff. So the idea behind this is that for the entire workflow in operations orchestration, we set a window timer. So this timer is gotten from the change control ticket that's dictated by your normal business logic of how long you want your change window to be. And the rest of the duration of the workflows, now that we're actually going to make changes to the server, are going to adhere to this patching window timer. So at any time, if let's say we reboot the server and connectivity testing continues to loop because the server doesn't come up, the connectivity testing cross-references um, the vulnerability management window itself. So it'll check to make sure that the time has not exceeded the window timer. And if it has, then it's going to do a failure and go through the exception route. And it's going to log that exception itself with the information that the patching was failed due to the time limit being exceeded. And that way you can dispatch incidents or tickets. So jumping back, so that's the patching window timer. Next is the pre-patch application workflows. So the idea behind this is your applications, your middleware, or any other of the special services on your server, they need to be gracefully stopped before the patches are applied to make sure everything goes smoothly. So inside Server Automation for our Apache server in our MySQL server, we have some start and stop scripts for Apache as well as the application Microsoft SQL services. So we can see here that step invoked the stop Microsoft SQL services as well as the stop Apache services scripts. So those are pretty straightforward. They just stop the Apache service. In this case, it looks like it wasn't already running. Um, but the idea behind this is you can get as complicated as you want. So if it's a database server, such as an Oracle RAC server, and you have your DBAs that have a set of scripts that gracefully stop CRS and then double check that there's no PMON entries in your running process list for running databases. So you have those scripts, and depending on where they're located, if they're located on NFS file share or network file share, or maybe on an internal Git server. So we can fetch those particular scripts once we match that this server matches that particular application or that particular middleware database. Then we can make sure those scripts are ran against those servers to go through the entire chain of how you want to stop your application. And of course, because you have the extensibility of orchestration, we have other things we can do, such as if you wanted to take a node out of rotation in a load balancer. So I don't have that loaded up for this particular POC, but you would be able to create those associations with, let's say, F5 big IP, and then make sure that that node is taken out of rotation before you do the patching to make sure you don't have any traffic being routed over there. It's as simple as adding in a subflow here to identify that server node and then find it in big IP and take it out of rotation. And then naturally apply patches once the application has been stopped. So we can see in server automation, it looks like the two Windows servers are currently remediating their patch sets, and the Linux server already had its patching sets applied to it, and everything was installed. So, of course, because it's a framework, you'd be able to plug in any of your other patching systems if you have them inside the subflows, so you can then branch from there. The idea is this top layer will just give the guidance of the proper routes to hit all the main modules. And then reboot server. So this is a managed reboot of the server. And in this case, it's running it through server automation, I believe. Actually, I believe it's being ran directly on the nodes themselves through PowerShell and through SSH to do the reboot. And then post reboot verification, making sure that the server is back up and connectable. And then running application startup. So we can see that over here, the Apache services were started back up. And then, like I said earlier, if you have your startup scripts hosted somewhere else, then be able to invoke those, parse the output, make sure that you have a clean startup. If not, log the exception and then put in the information for why there was an issue and determine your logic of dispatching the right application teams for application issues. And then we have a post vulnerability scan. So we're going to pop back over to that IIS server that ran the first vulnerability scan. So if I refresh this one, we can see now, if I look into the details of the pre-patch security scan, the idea behind it is that it ran the security scan and then it pulled back, in this case, a final score. So that's how they scored. The higher the score is, the more vulnerabilities. So you want a low score. So it's going to grab the before and after scores, and that way you have more showback to auditors or anyone that wants to show that these security patches have been applied and it has reduced the vulnerable surface area of that particular target OS. So it looks like our Apache server has finished. So we can see here it finished. And if I go back into Slack, we can see it posted information about it being finished in Sitescope. We can see that the ping monitor is back up. So this .141 is actually that Apache O2. So we can see it's re-enabled since the server was back up gracefully. And if we go back to our flow chart, so that would be post security scan. We skip that on the Apache server because it takes a while. Re-enable monitoring and then updating the change ticket with that information and then sending out completion notifications. So at this point, does anyone have any questions?
Yes,
So
Andrew,
there's a
Sebastian
couple of
speaking.
questions in the Q&A.
Yeah, Sebastian speaking. I have a question. Andrew, you were talking about your timing purpose or timing windows you set at some point to define how long you will let the servers being patched by SAA.
Yes.
What happened if your timer was too short and the servers is still doing the patch correctly? So you're going to send notification to users, I suppose.
Right. Yeah. So that's a good point. Have a little bit of echo. Okay. So the idea behind that, right? So you set the patch, and then let's say the patching process in server automation is an active job, and it's just taking a long time, maybe 4 hours. So right now, the automation in the framework going to is not going to say, okay, it looks like right now I'm running this operation. This operation is taking 4 hours. So in that use case, it's not going to help. um, so in operations orchestration, it'll do that operation, and then the next operation is to check what the current time is against that window. So if I actually looked here, um, then I would see that it's checking the window after the operations. And if the actual job within the existing operation is taking longer, it's not going to catch that and then be able to stop that job. So that's not how it's currently written. There is a possibility for you to do that, but it's kind of um, implied that under this workflow, that it'll wait until that operation completes to see how long that operation took and then compare it against the window time. So you would have to branch off um, branch off the main workflow and time something independently that's running externally to be able to do that kind of operation. Like you'd have to kick off patching in server automation and tell it not to wait for the patching job. You would just ask for the patching job ID and then do a constant iteration every 5 seconds or so. It says, is the job completed? Is the job completed? So right now it's just waiting for the entire job to complete before it does the next operation. So you can do that. Any more questions?
Yeah, this is Jay here. This is Jay. I your demo is not just you're targeting server by server, right? So every schedule is for a server. Is there a specific reason why you have done this, or is it just a use case?
Can
Generally,
you
what
repeat
happens
that
is no. Generally, what
one more
happens
time?
is most of the time it would be a group of servers kind of stuff. So is it something which you tried at some customer place, or is it something which is done only for the demo purpose? Some kind of a framework you've developed. So
So we have some customers that are doing similar things. So the idea behind it is integrating with the CMDB to see when their current servers already have a predefined patch window made for them, and then
mhm.
scheduling each one of those servers. So it's kind of closing the gap between in the CMDB knowing what vulnerability window a server needs to be assigned to, so it can be patched in that window, and then pulling that information and saying, okay, here's the next set of servers within 24 hours that need to be patched at these times, and then creating the ticket and actually patching them at that particular time.
Okay. So I do have a customer who was actually having this similar need recently. Uh, in fact, they are not using server automation, but they have a lot of products, disparate products, but they don't have any orchestration platform. We try to give a solution, but it's not yet worked out. Is there somebody I can talk to you after this call?
Yeah, so you can send in an email to the to us. I believe you should have an HPE email that organized this particular meeting, and then we can work with you from there.
Okay, maybe Michael Button, or anybody who should I
Yeah,
talk
yeah.
to? Okay,
So he's a good point of contact for this as well.
sure, I will do that. Thank you.
Andrew, Sebastian speaking again. Question about O performance. We know that by experience that O doesn't like to have um, long flow running. So if you have to apply that flow to, let's say, 1,000 of servers, is it not going to impact O performance?
Right. So that's a good point. So within this design, you have to keep in mind that each one of the running operations is going to consume part of your JVM heap. And naturally, if you have 1,000, you're eventually going to consume all your JVM heap, and then it runs into issues. So this particular demonstration shows it as one continuous flow that can take a long time, but you can break it off. So you can modularize it into separate pieces, such as doing something like so you would run the first set until your next large item, which is maybe your security scans. If you know your security scans can take 10 minutes, then when you scale that by 1,000 servers running security scans, you don't want all that JVM consumed when it's not really doing anything. It's just waiting for a response. So instead, what you would do is you would have that flow invoke security scan and other large items such as patching server, invoke those processes to those external tools, and then it would schedule a follow-up flow within OO scheduler with all the appropriate information to resume after, let's say, 10 minutes, 15 minutes, something like that. So at that point, your flow would stop, it would be completed, it would reschedule the flow to resume at a certain amount of time, check to see whether or not the operation that it last did was finished by doing that same query to the external tool. And if it is, it would continue to the next step, invoke something like patch server, and then complete. It wouldn't wait for patch server to finish, but it would schedule itself to resume this workflow. And this workflow would start with check to see if that particular job has been completed. If not, go ahead in the flow gracefully, reschedule it to resume. So you would do something like a complete the
So
flow,
you,
schedule the
yeah,
flow to resume a later time. That
yeah, I
kind of
understand. So you have a probably a master flow somewhere running and checking for flow which are in pause mode and resume the flow depending on criteria, I guess.
right. But it wouldn't be pause and resume the flow because I believe that would also consume JVM memory, um, even if it's paused, because it would still take up that JVM. So this would be to have the flow complete, but schedule the flow within OO scheduler to start again at a different starting point um, at a certain time, and that starting point would first check for whichever module you stopped at. So this particular master flow here wouldn't work in that scenario, but it would see lots of different things like launch flow. So it would have a um, like run security scan, but inside the subflow, instead of waiting for the security scan to finish, it would just say run security scan, and then it would complete the flow. Well, it would run security scan, and then it would run a dynamically launch flow that says in 15 minutes um, schedule another flow to run with these inputs to tell it where to jump to when you start the next flow. So the next flow can start right here. And during those 15 minutes, you don't have that flow running anymore. So the JVM is now released back to the JVM pool, and you're optimizing your RAS workload
Andrew,
placement for your jobs.
yeah, don't we have a new functionality in OO, which is Hibernate, a kind of Hibernate where we release all the memories and GVMs and whatever performance or process we can use? I guess we have now, no, isn't it?
I
Well,
don't know
maybe
for
a side
sure.
question. I don't want to. I don't.
Right. I don't know the answer to that off the top of my head, but it sounds like if that's one of the new features, then that would be optimal to use to kind of create a hibernation period between operations that you think are going to take a long time, and then have it resume, check to see if the operation is done, and then continue its life cycle. So you can scale it and optimize your JVM resource utilization.
Thank you. I understand the concept.
Do we have any more questions?
Can
Hey,
you hear
Andrew,
me?
this is Pat Davis. I was going to say we put some questions in the Q&A at the bottom there. If you
Oh,
want to, I can speak to those, or if you just want to go through them.
I'll go to the Q&A now. So the first question is converting the times in the CMDB to the server local time and scheduling, or assuming a standard time zone for all servers. So that's a good point. So what you'll want to do is design your workflows for integrating with the CMDB for those particular vulnerability times. So it depends on the CMDB, or maybe it's just a regular database, what that database time is set to. But you'll set a best practice for maybe sticking to one particular time zone, perhaps UTC time. So whenever you get a pull from the CMDB or any external data source about dates and times, you make sure that you format that date and time using the OO pre-built operations for time zone conversions, and you make sure that all your inputs for or all your external integrations get things and return them back in UTC time, and everything locally runs in UTC time. Just setting that standard up front and saying, for everything I'm going to develop, I'm going to do it in UTC time. So that would be how we would approach that. Definitely choosing one particular time zone and then sticking with that necessary within the workflow itself to make sure things match. So the second question, how much of the OO flows are customized out of the box versus developed from scratch? So all the actual flows here are pre-built integrations. So all the server automation integrations are done with server automation content pack, email notification, database updates, all stock. Flow variables is just variable manipulation. Um, File system checks, change request. So for all the ITSM products, those are pre-built integrations. You can get off HPLN. Generating start and end time. That's just using the the date operations. Um, Pre-connectivity testing. So this is just using port checker, which is an integrated thing to do pings and checking if SSH. So that's a port ping test. Same thing with RDP, running the test commands using SSH operations. Everything in here is all pre-built. So the only thing that wasn't was Nextpost security scanning vulnerability products didn't have a pre-built integration. So that was a HTTP post call. But yeah, everything is using pre-built integrations. Um, and then everything down here is mostly server automation or direct SSH slash PowerShell or Windows WMI calls for getting OS information. The next question is, in the patch vulnerability scan section, is there logic in case a vulnerability is still found to try and remediate again? So currently, it isn't. So right now, it's just running the vulnerability scan based on a pre-made template within the Nextpost scanning engine itself. So if you wanted to do something like your patching was to get rid of maybe Heartbleed or something very specific, so all the vulnerability scanning engines that you have within your infrastructure. So part of the calls out to them is you're going to be able to get a list of the resulting vulnerabilities. If nothing else, you'd be able to invoke the email or the XML result of what that is, and then do parsing on XML or that plain text to see if that particular vulnerability ID is still there before or after. So that's not implemented in this right now, but you would just simply parse more information than I am, because I'm just getting the vulnerability score from the actual HTML result that I did a HTTP call against the security scanning engine with. And you just look for a different item in there, whether it's a RHSA particular ID or CVE, that kind of thing. And then if you found it, of course, you'd be able to remediate again, but you'd probably first want to do a little bit deeper analysis on your OS patching and do something like a query into which OS patches are being applied to make sure it matches that CVE, so you can cross-index to make sure that that Heartbleed vulnerability package update. I think that was Heartbleed was I forgot which particular package it was that was updated. It might have been OpenSSL was Heartbleed. Anyway, so you'd be able to do that. The next question is, if you are targeting 5,000 servers, then you cut the big flows into subflows. You'll create thousands and thousands of schedules. Will OO Scheduler be able to manage this kind of workload? So in my experience, I've only worked on scheduling maybe it's in the under thousands. So maybe like 700 servers were scheduled to be patched in that 24 hours, and then set up that schedule. I don't know the limit to the scheduler, how many the scheduler can handle. I'm sure that's published somewhere. I just don't know off the top of my head. Um, but in terms of the scheduler, I would think it could do it because the scheduler doesn't do too much except for schedule things. The only thing you would run into is when all these concurrent servers are being scheduled at the same time, like they all have a patch window of 3 o'clock a.m., like right on the dot, then you would kind of have an overload of all these things being kicked off, and you would start hitting orchestration pretty hard with its API call to say run this particular flow. So what you would probably do is create some variance in your patching automation to plus or minus 15 minutes, 20 minutes, or something reasonable, so you can kind of spread things a little bit more as long as it adheres to your vulnerability management window itself, so you don't overload. It's the same thing with VMware when you're deploying a lot of VMs, right? You don't want to deploy 100 VMs at the same time because you're just going to kill your backend LUN and then cause performance issues with everything else. Same thing applies here from um, a theory perspective. You don't want to hammer a bunch of new workflows hitting at the same time at too much scale. It could affect some of the other workloads that may be doing other mission critical processes that are now delayed a little bit. So you have to kind of design your approach for that. And you also have the ability to spread your load across multiple centrals when you scale everything horizontally. So as long as you're doing your scheduling across the front end load balancer, then you make sure that the um, actual executions are happening across the different centrals. So the next question is this set of flows to be officially released as a product slash add-on? Do you plan to make it available internally? So I'm going to be releasing it as community content onto HPLN, um, but it's not an official product add-on. So it'll just be available to consumers or purchasers of the OO Central product itself or any of the greater suites it's on. And then you can go out on HPLN and look under community content, and I'll be releasing it there. Next is the Slack integration out of the box, or is that a REST API call to Slack? So currently the Slack integration is a REST API call, and it's just using the HTTP service. Um, but I need to double check back on HPLN because I believe we have community content now for Slack integration. But really, it's pretty simple because you set up your particular hook. Um, so don't steal that particular private key that I just showed you for my Slack instance. Um, so I'd have to check on that, but I can get back to you if now it's part of the out of the box integration sets as a HPLN add-on that you can search for. So the next one is, how are you managing and importing the OS patches in Server Automation? Are you just importing all the patches for each OS and assigning them to all the managed servers by OS platform? So in terms of patch management within Server Automation, so the approach I took was, so of course any process you take can be customized to the way that you do things better. Um, but the idea behind the framework is you want to keep everything not abstracted as much as possible. So in Server Automation, I have a software policy called Red Hat 6 patch set, and then the same thing for Windows. So these Windows OSs, I think were 2012 R2. Is that right? Yeah, so they were 2012 R2. So what I did is I created a software policy with those particular OS flavors, just very generic. And then there's a sub policy attached to that that are the current patch policy for that particular month. So that way, within the operations orchestration, you're running against the same software policy every time you run patches this month, next month, third month. But your QA teams that are in charge of bundling the patches together, they're going to update that particular patch set for that month. So for this would be the May one. So we'd have a sub software policy in May or a sub patch policy in the Windows space called May 2017 Windows 2012 R2 patch set. And that's the ones that they decide I either want all of the new patches or I just want some of them. So that's where you decide what patches are going to be applied, but that will be a child software policy within the main one. So that way it's a little bit easier to keep your automation workflows consistent and the same, but you just plug in and out the different child subsets. That also helps you do things such as like if you want to do a rolling upgrade of software like MQ series, something like that, you would be able to add another child package of a tested process where you uninstall the existing MQ or check for it and then install the new MQ, things like that. So you can do rolling software updates that are kind of external from patching, but they're just utilizing this automated framework to do incremental deployments of anything into your OS stack and your third party stack. So let me go back to questions. So that was that one. The next one is, will this replace server automation? So this is just a framework for integrating into all the different processes you have that you have to do to change a server, integrating with ticketing and change control, and you still have to integrate into your source that has the patches. Like operations orchestration isn't a hosting artifact repository for patches or automates the imports of patches and things like that. It's best suited to integrate into all your different disparate products to utilize the best tool for the best job for each one of the things you have to do, and then creating this linkage, just like the architecture here, to make sure that you have the consistent process and workflow as you're hitting each one of these items, and you're able to, for any issues or any extra information, consolidate those all together and be able to report that out to the users that want to make use of that information, whether it's through Slack post about this or sending out confirmation emails after things have been done, such as this is the resulting of one server being patched, right? So we have pre-patch information, post-patch information, and then for each one of our tiers, we had timers on it, so we know how long each subset took, whether it was completed, whether it failed, what the score on the security scan was. So each one of my operations had custom HTML. So at the very end, I could have this very complete HTML roll-up email. So that was something I included there. So we have a more rich delivery of the automation result end user. All right. So does anyone else have any more questions? All right. Then with that, I'll give it back to Andre.